Hello students. So this is from the first chapter, that is matter in our surroundings, and this particular video covers the properties of gases. Okay, so come, let's have a look at it. So the first property of gas, that is gases are highly compressible. So in this particular activity, what it is given to you, that we are compressing the gas using a syringe. Okay, and at the one end of this syringe is blocked with a rubber cork, and we try to push or compress the gas with the help of a piston. So what will you observe? We'll observe that after a moment, we, even if we try hard, but we cannot further compress the gas. That means gas is a matter, and with the help of this piston we can compress a large amount of this gas. If we try to look at a similar experiment, so let's have a look on this animation where you can understand better. See, these blue dots are gas particles, and this is the movable piston, and when we keep on compressing it, we can compress it till the spaces between the particles is almost similar to the spaces between the particles of liquid. That means gases can be compressed and changed into liquid. So this is the reason why gases are compressed and filled in the different containers like LPG, CNG. All these gases are filled in different cylinders. Yes, the cooking gas, that is the LPG, are available in different cylinders that are generally used in our home. So how they are filled? The LPG, that is the liquid petroleum gas, is compressed and then they are filled on these cylinders. So this particular mechanism is used. Okay, so what generally it is done, that this particular gas, so these are the particles of gas. Okay, and these are compressed to that extent that the spaces between them are similar to those of the spaces between the particles of liquid. Okay, so now this one, we are compressing the gas particles till the spaces between them become smaller and smaller so that it turns into liquid. Okay, so from this experiment we can know that due to high compressibility of gas particles, or due to high compressibility of gases, a relatively larger amount can be filled in a very small container. See, the yellow portion that represent the gas, and the small container is represented by the red rectangle. So what we can see, that a large amount of gas can be compressed in a smaller container. Okay, so in the next slide, that is the second property of gas, that is gases diffuses very fast into other gas. Okay, so these vapors that is coming out of the food dish. Okay, so these are the aroma of food, and the particles of this food aroma, it mixes with the particles of the air, that is the gases in the air. Okay, and when the particles of the aroma from the food, it diffuses with the air, these particles of aroma of the food reaches to us, and we get the smell of any hot cooked food in the kitchen. Okay, so why this takes place? This takes place because diffusion of gas particle in gas takes place at a very high speed. Okay, and this takes place at a very high speed because the particles of gases have a very high velocity, or they can move very quickly, very fast, and the spaces between the gas particles are larger. Okay, so this can again be looked at by another experiment, this one. So what this experiment represent, look over here, these blue dots are one of the other gas particles, and these red dots are other gas particles. Okay, these are two separate different gases, and they represent, the dots represent different two gases. Okay, so when we remove the green barrier, the red dots and the blue dots, that is the particles of one gases, it diffuses into the particles of other gas. Okay, so what we can see, that here the diffusion takes place, the boundary or the border was this dotted line, and when it was removed, we can see that diffusion of both the particles of two different gases occurs. So this is an example of diffusion of gas into gas. Okay, so if you want, you can have a look at it again. So these are the particles of one gas, and this is of another, and this is the barrier. So when this barrier is lifted, so this particular barrier is lifted, the gases of two different particles will diffuse into one another. Okay, so this is the diffusion taking place. Okay, so our third property of gas, that is gases exerts pressure on the wall. So why gases exert pressure on the walls of the container? It is because the particles of gases, they move randomly, that is they can move in any direction with a very high speed, and due to this movement, the particles of the gases, each particle of the gases will hit the wall of the container at one or the other point of time. So they will hit the wall of the container with a definite speed or definite force, and that force will exert a pressure on the wall, that because pressure is nothing but it is force divided by area. Okay, so pressure is equal to force per unit area. So when the molecules of the gas or the particles of the gas will strike the wall, it will exert a pressure on the wall of the container. Okay, so this can be again looked up on this experiment. So here the blue dots, it represent the particles of the gases, and you can see they are a random movement. So there is no definite direction and they are moving at a very high speed. Okay, so when they move at a very high speed, they are striking these walls of the container. These are the walls, and they are striking the walls of the container. Okay, so they will exert a pressure on the wall of the container. So we say that gases exert pressure on the wall of the container. Okay, so now these are the two different properties of gases again, which are not included in your book, that is gases have lower density. So you can see, as compared to solid, this is liquid and this is gas. What we can see, in solid the spaces are very less between the particles. In liquid the spaces are higher than the particles of solid, but it is lower than the spaces between the particles of gas, and in gas the spaces between the particle is maximum. Okay, so what will happen in an unit area? So in this picture it is represented by the squares. So in a definite volume, the number of particles of gases are lower than that of liquid and that of gas. So what will happen? The mass will decrease. As the particle number of particles will decrease, the mass of the particle, the total mass of the particle will decrease in a definite volume. So what density is? Density is mass per volume. So at a per unit volume, for gases the mass will decrease, and due to this the density, so density equals to mass by volume. So what will happen? So as the spaces increases, the number of particles will decrease, and due to this the total mass of the particle at that unit volume will also decrease, and due to this the density will decrease. So since the particles of gases have higher space between them, it will have lower density. Okay, and the other is gases have higher volume. Okay, so this we have already know that gases have higher volume. Okay, so these are the properties of gases, and have a look at it, and if you have any problem, any doubt, you can ask me in your live Zoom classes. Okay, thank you.